Welcome to this explainer. Have you ever spent just hours tracking down a single solitary missing character in your output? It's maddening, right? Well, today we are diving into Ang's notes on Haskell programming to crack a really specific, kind of fascinating micro-mystery. We're going to look at exactly how data can just silently vanish inside our code, and more importantly, how to catch it red-handed. Let's jump right in. So, to set the stage here, this case file comes directly from part 171 of Ang's ongoing Haskell notes. And honestly, that number alone, 171, shows some serious, hardcore dedication to tracking down the absolute smallest of coding discrepancies. Now, we aren't looking at some massive, catastrophic system failure today. Instead, we're looking at a super localized, highly specific formatting bug. But you know what? Often it's these tiny bugs that actually teach us the most about how our underlying tools really behave under the hood. All right, Section 1, the missing separator mystery. Let's investigate this TXT output. Okay, so during a totally routine test of a TXT format output, Ang explicitly noted this glaring issue just hiding in plain sight. Basically, the chapter header separator, which is this full-width colon, was completely missing from the final document. Now, this colon is a distinct typography block that was supposed to make the whole document readable, but it's just vanished. No error messages, no warnings, literally nothing, just gone. So this leads us to the absolute crucial question: how does a specifically typed character just disappear from a compiled final document? I mean, the build didn't crash, the parser ran totally smoothly, but this separator just seemingly walked right away from the scene of the crime. Moving on to Section 2, investigating the parser code, where we'll follow the data's path. By tracing the data backwards, Ang found a pretty critical distinction. The parser was actually working. Well, partially working anyway. It successfully matched the character, effectively acknowledging, hey, the separator is here. But, and this is a big but, it was matching, it was not retaining. It actively chose not to hold on to that character for the next step in the process. Which brings us to Section 3, the culprit named void. Literally the document shredder of code. So here's what happened. The original parser used a function called void. Now, in Haskell, void is specifically designed to consume the input, but intentionally discard the result, returning what's called a unit type. You can really just think of it like a digital document shredder. It successfully accepted our full-width colon, which, hey, prevented a crash, but then it just tossed the data straight into the trash, leaving absolutely nothing but an empty placeholder behind. All right, Section 4, capturing the separator and rewriting the parser logic. Let's take a look at the exact code diff here. The original code wrapped the separator logic in void, literally telling the program, hey, look for this string but then throw it away. Obviously not what we want. The fix removes void completely so that one of strings actually returns the character itself. And notice this clever secondary change too. The space alternative now uses a functor map to return a space string. This is crucial because it ensures both sides of the parser alternative return the exact same type. Okay, so now that the parser isn't destroying the input, our data actually survives. The next logical step in the Haskell code is to explicitly capture that surviving separator into a variable, which Ang aptly named sep. By binding the matched string directly to sep, the program securely stores our previously missing full-width colon right there in memory. Now for Section 5, fixing the hard-coded space. This is the final piece of the puzzle. If we switch gears and look at the document generation side, the original code used a hard-coded single space regardless of what the parser found. It essentially just assumed the separator was a goner anyway. But the new logic changes this entirely. Instead of forcing that hard-coded space every single time, it dynamically checks if a separator was actually captured in our new sep variable. And if it was, boom, it inserts our newly rescued full-width colon. Let's just break down this super elegant fix into 3 simple, highly logical steps that successfully patched the bug and completely restored our chapter header formatting. Step 1, remove void from the parser logic so it just stops shredding our text. Step 2, actively capture that surviving separator into our variable called sep. And finally, step 3, go over to the output generator and replace that lazy hard-coded single space with our dynamically captured optional separator. Honestly, it's just a beautiful, really clean fix. And that brings us to Section 6, case closed. Let's summarize the fix. We followed the journey of a single, highly specific missing data point today. Routine TXT testing revealed a missing full-width colon in the chapter headers. So we dug into the parser and found the destructive code, that pesky void function, which was silently shredding our matching data. By removing void, we allowed the parser to actually retain the character. And finally, we made absolutely sure that the successfully captured separator replaced a hard-coded space in the final output. Now that TXT document looks exactly as intended. Problem solved. But, this whole micro-mystery leaves us with a fascinating and honestly slightly unnerving question about our own codebases. Where else might an optimization or a function exactly like void be silently and efficiently erasing data context that you actually really need downstream? It's such a great reminder to question not just if your code is compiling, but exactly what it might be blindly throwing away in the process.